Simulation is a powerful tool in statistics. In a simulation, the computer conducts experiments for us. Computers can carry out thousands of experiments in a matter of seconds. We can analyze these results to answer what-if questions. In this video, we'll introduce a basic experiment called the EARN model. It's a simple chance process that can be used in many ways. Let's start with an example. Suppose our experiment is to roll a die 10 times and we want to record the proportion of the die landing 1 or 6. Well, if it's a fair die, then each outcome will be equally likely. Here's an EARN model that's equivalent to rolling a die 10 times. Since it's a fair die, we would have one marble for each possible outcome, and then we mix the marbles around, draw from it once, we might get a 5, and then we want to replace the marble back in and then draw once more. The second time we might get a 6, and then we repeat this whole process 8 more times. We might get numbers like these. So from this, we got 3 6s and 1 1. That's equivalent to saying we got 40% of the outcome being 1 or 6. Well, since we're only interested in the marble being 1 or 6, that's equivalent to changing the numbers on the marble to just 1 or 0. So we can say we have 2 marbles labeled 1 and 4 marbles labeled 0. And the drawing from above, we can actually convert these numbers to 0, 1, 0, 0, 1, 0, 0, 1, 1, and 0. If we add these all up, then we would get 4. And since we draw 10 times, that gives us the 40% that we thought we got. Let's see how to conduct an experiment with simulations in R. The values on our marbles was 0 and 1, and we actually had 4 marbles labeled 0 and 2 of them 1. To create the EARN, I can use the rep function that will repeat each element in vowels a certain number of times. And so we can get the EARN this way. Notice I have 4 zeros and 2 1s. To draw from the EARN, I can use the sample function. To draw from the EARN, size argument indicates how many draws will you make, and the replace argument indicates whether the element drawn is replaced in between draws. Notice that each time I call this, I get a different outcome. And to count the proportion of ones, all I have to do is add these up and then divide by the number of draws, which is 10. That's actually equivalent to taking just the mean of the outcome from the sample. Again, I can get different answers because each time the sample is different. To repeat this many times, I can use the replicate function. The first argument to the replicate function is how many experiments you want to conduct, and afterwards, the second argument is what code you want to repeat. Let's store this in a vector called results. Now that we have the outcome of 10,000 experiments, we can look at the first few. I can also look at the results, the 4,000th outcome, which is 0.3, or even the 131st outcome is 20%. I can also take the average of these results to get an estimate on average, what do we expect? So that's 0.33, which kind of makes sense since 1/3 of the marbles were 1 and 2/3 were 0. I can also get an idea of the typical spread by taking the SD of the results. You can see that. I can summarize the data using a plot like this. We can note that the most frequent outcome was 3 out of the 10 draws being 1. The next one was 40%. Note that 0.3333 is not a possible outcome here. That is just the balance point of this graph, but not an actual value we might get. Also, we can use the graph or the vector results to estimate what proportion of times can we get 80% or more. So note that our data, 28 experiments out of the 10,000 got 80% or more. So if someone rolled a die 10 times and got 8 times out of the 10 were 1 or 6, you'd be very suspicious of the die being fair, since this is a very rare event. Let's summarize the key elements in our EARN model. First is the marbles, which is which values do we have? And then how many of each values do we have? Then about the draws, you can ask, well, how many draws will we make? And whether the draws are done with replacing the values or not. Lastly, is how are we going to summarize the outcome of the draws? For a simple die tossing experiment, we only had marbles 1 and 0, and we had 2 1s and 4 0 marbles. The draw we've done 10 times with replacement, And lastly, the way we summarize was just calculate the proportion. Now let's talk about the Salk trials relating to the polio vaccine. This was an experiment with 400,000 children, where half of them were randomly assigned to receive the vaccine, and the other half was given the placebo, which was just salt solution. Of those who got the vaccine, only 56 got sick, and out of those who got the placebo, 142 got sick. So it looks like the vaccine's working, but you can always ask whether this was done by chance or not. Meaning, let's suppose the vaccine does not work. So the 198 kids were going to get sick no matter whether they got the vaccine or not. So the fact that we got 56 in this group and 142 in that group was all due to the random assignment and not because of the vaccine was working. So what's the earn model in this case? Well, we have 400,000 marbles since we have one for each child. We can say the marble is 0 for the healthy children and the marble is 1 for those who got polio. In that case, we have 399,802 marbles that are labeled 0 and 198 labeled 1. We're going to make 200,000 draws, and those will go into the treatment group, meaning they got the vaccine, and we're going to draw with no replacement since we cannot give a child the same treatment. And to summarize, we're just going to sum up the draws. Now let's do the simulation in R. Again, we have marbles labeled 0 and 1. And for the counts, we have 399,802 healthy, 198 sick. To create our earn, we use the rep function. And now from each time, we're going to sum up our draws from the earn. We're going to draw 200,000 with no replacement. And we're going to repeat this experiment 10,000 times and store it to something called results. This replication, the simulation, is actually going to take a while, and we're going to fast forward here. Out of these 10,000 experiments, now we can see how many of them did we get 56 or fewer sick children. Notice that none of them happened, so this is an extremely rare event. Therefore, it's very unlikely that this is by chance. Our last example is an experiment of whether calcium can lower blood pressure. We got 20 men separated randomly into two groups. One received a calcium pill for 12 weeks, one got a placebo for 12 weeks, and these are the numbers that represent the amount their blood pressure decreased over the 12 weeks. So the first person, their blood pressure lowered by 7, second person, blood pressure increased by 4, and so on and so forth. Overall, it looks like the calcium pill is working. However, you can still ask whether this is by chance or not. Meaning, assuming the calcium pill does not work, and the reason these values are in the calcium group and the others are in the placebo group is simply by random assignment and nothing due to the calcium pill itself. Let's make the earn model for this case. We have 20 marbles overall, one for each patient. The values on the marble is going to be the blood pressure decrease values. We're going to make 10 draws with no replacement, and in the end, we're going to calculate the mean of the 10 draws. Now let's simulate this in an R. To create the earn, let's combine the calcium group data with the placebo group data. And then each time from the earn, let's sample 10 people with no replacement, and each time I'm going to calculate the mean. And to simulate this, I need to use the replicate function, and let's replicate 10,000 times. And let's store the results and results. Now let's see, well, what fraction of the time of our experiments did we get something greater or equal to the actual calcium group data? That only happened roughly 6% of the time, which is quite rare. We can also look at the histogram of the results to get a general idea. Now you know how to simulate an R, you can do various experiments on your own.